Hello, respectful teacher and classmate. Here we ADS team, including Michael, Douglas, and myself, Minghui, will present our network on EEL 5718 Lab Project 1. And we'll go through every single step. Let's start with the RYU manager and enable the NAT controller. That one is up running, great. Next, we go to terminal and set up the networking topology with the Mininet. Once we set it up, we use the pin O command to verify current network connection. And you can see there, host H1, H2 is cannot find each other, and the path is broken. That's how we started. Next, we go to X terminal, switch S3, and set up the bridge and IP forwarding.
Okay, IP forwarding is now set up.
Perfect. After that, we go back to Mininet command line. At this stage, we'll work on static route setup. So Douglas, it's your turn.
Yep. All right. So
Please.
hello, name is Douglas. I'll be going through the process of setting up the static routes for the ADS group. So we're going to want to set up the static routes on the server and the client, and we'll use the IP command to set up each of the routes. So on the host one terminal, you can see the current routes. However, we need to go over to the Mininet and actually type in the static routes to be added. So here's the host 2 IP route to add, and then followed with the host 1 static route that we are adding. And if we go back and type in the IP route show, both of those routes are indeed there. Yep. Host 1 and host 2. So now we should be able to go back to Mininet and send a ping from host 1 to host 2. Great, it's working. Both of the machines are able to talk to each other.
Wonderful. Now the path and the route has been set up, and we move on to next step. We'll go back to host 1 and host 2, set up the TCP dump there, and for packet monitoring. Perfect.
All right, so this is going to be the TCP dump for H1. This one is TCP dump for H2. And this is going to be the actual
next
terminals we
one,
use.
we'll proceed to the client server communication setup, we are going to use Netcat for this interaction testing. So on the client side, we see hello. Typing hello, and then we can see hello show up under server H2 side. And as an opposite direction, we say hey, and we see that show up on client side H1. Wonderful. Okay, I'm going to explain another networking performance benchmark tool, iPerf. iPerf is an open source popular tool for networking speed testing and the bandwidth test measurement. Basically, we can set up under client and server environment and running TCP or UDP for testing purpose. And in addition to that, the iPerf command is also working under Mininet environment command line, and wish to be able to verify that if time is allowed. And you can see here, we already started testing for, Michael is a TCP, right? Or
Yeah, I just ran TCP right now, and I'm about to run UDP.
perfect. So that's
Yes.
about the tour, networking tour, Netcat and iPerf. And Michael will demo and show the data on TCP testing and the UDP testing.
Yeah, so to explain and demo that TCP and UDP are both working, as you can see, we ran NCAT and the messages were coming across each way. For a little bit more of an in-depth test, we ran iPerf. The first one I did was TCP, and we saw a bunch of TCP messages. And I just did the UDP, and here we can see a bunch of UDP messages. It says UDP all the way through on each one. These are currently, as we said before, just a TCP dump of what's coming across the server and the clients. And we see that it's making connection, it's sending back and forth. So this is pretty good proof that both TCP and UDP are working.
Great. So for a wrap up, and we just want to show a little bit more detail on this particular design networking. Michael, please go back to Mininet command line and just type in the IP command, networking command dump, or yeah. From here, we just want to highlight again, we're designing with this simple network topology, including H1, H2, and the switch S3. And with each one has an associated IP address and device ID. So we start from scratch, and with the open floor controller implementation, we're able to realize the function of network address translation. As you can see, these two address for H1, H2 is quite unique and different, and obviously on very different subnet. And in the end, we're able to make them talk to each other with both typing verification and TCP and the UDP verification as well. Okay. I think that's the end of our demo. If you have any question, please shoot us a message on Canvas or email. We'll try our best to answer. Thank you.
Thank you very much.
Thanks.
Perfect. Let me close.